guys. We're going to be going over the second part of your homework tonight. So we'll be looking at problems 9 through 13. The first thing I want to tell you is that there were some mistakes on the study guide. So I've corrected them here on the video. So if you were a little bit confused about anything, hopefully as you watch this video, it'll make a little bit more sense. So you'll notice that my models look different than the ones on your paper. That's because we forgot to change the models when we changed the problem. So let's look at number 9. Number 9 says the area model shows 1 1/10 times 1 2/10. Use the model to find the product. Now here's the deal. If you don't like models, you don't have to use the models. How is anybody going to know if you used them or not? What we care about is that you're able to find the product. You can do that using the model, or you can do that using standard algorithm. So let's use the model and then we'll do standard algorithm. Using the model, I see here 1 whole and 1/10. Down the side, I see 1 whole and 1 2/10. So there's my 1 whole and 1/10 times my 1 whole and 2/10. My answer can be found with what I see inside of the rectangle. So inside the rectangle, I see 1 whole, and I see 1, 2, 3/10, and I see 2/100. And so that tells me that the answer to 1 1/10 times 1 2/10 is 1 32/100. That's how I could use the model to find the answer. If I wanted to solve it using the standard algorithm, I'm going to line up my numbers. Remember, when we multiply decimals, we line up the digits. We don't line up the decimal points. These happen to line up, but the very first thing that we do is hop that decimal out. And so we're actually doing 11 times 12, which is a math fact, but just in case you forgot it. 2 times 1 is 2, 2 times 1 is 2, 0, cross out. 1 times 1 is 1, 1 times 1 is 1, add them up, up, up. 2 plus 0 is 2, 2 plus 1 is 3, and 1 plus nothing is 1. The last thing that we have to do is hop our decimal back in. If I took 2 hops over here, then I need to take 2 hops over here. 1, 2, that puts our decimal between the 1 and the 3, giving us the same answer of 1 whole and 32/100. Either way you solve it, that's the answer you should get. We're going to do the same thing over here in problem 10. Again, we're looking at the model first, and then I'll do the standard algorithm. 2 times 1 1/10. So we see here 1 whole, 2 wholes, so across the top is our 2. And going down the side, we have 1 whole and 1/10, which is our second number. Our answer can be found within the model. So that's 2 wholes that I see and 2/10. So our answer to 2 times 1 1/10 is 2 2/10. If I want to show that using standard algorithm, I'm going to put the 1 1/10 up there first and the 2 below because it's a 2-digit number and a 1-digit number. Again, I do not need to line up decimals. I'm simply lining up digits because the very first thing that I'm going to do is take that decimal out. So it's really an 11. And we know that 2 times 11 is 22. The last thing that I'm going to do is hop that decimal right back in, giving me 2 wholes and 2/10, which is the same answer that I got when I looked at the model. So again, either way you do it, your answer should be 2 2/10. So that's how you solve multiplying decimal problems using models and standard algorithm. And you can be sure you'll see some of those on your test. Now let's look at number 11. Justin has 3 containers. Container A holds 2 68/100 liters. Container B holds 2 68,000 liters, and container C holds 2 7/10 liters. Justin says that container B, that was this one, holds the greatest amount because 2 68,000 has the most digits. Do you agree or disagree? Well, Justin's right that it does have the most digits, but he's definitely wrong that its value is the greatest. Even though it's got 1, 2, 3, 4 digits, we have to look at the value of those digits. And the value of that 68 is in the thousands place. So he has 68 thousandths. But look over here. Container A also has 68, but that 68's in the hundredths place. So container A has 68 hundredths. Hundredths are bigger than thousandths. So actually, container A holds more than container B. But wait, head on over to container C for a second. There's only 2 digits, but look at the value of that digit. That 7 is in the tenths place. That means container C holds 2 wholes and 7/10. 7/10 is bigger even than 68/100 because I can always put that 0 behind it and turn that into 70/100. So actually, container C holds the most amount. So I disagree with Justin because it doesn't have anything to do with the amount of digits. It has to do with the value of those digits. Let's move on to the next problem. Number 12 was also one that we had to fix. We forgot to change down here to 3 6/10. So make sure that you do that before solving the problem. All right, the problem says to use the model to find the quotient of 3 6/10 divided by 3. Again, if you don't like models, you don't have to use them, but you do have to find the quotient. So I'm going to show you how to do it with models and then how to do it with partial quotients. So this right here is my total amount. And you can see that we've already shown you the total right here, 3 wholes and 6/10. 1, 2, 3, 4, 5, 6. I'm going to divide that total into 3. 3 what? 3 groups. I'm going to turn it into 3 groups. That tells me that whatever my answer is going to be what's in each group, or groups of. So if I'm going to separate 3 wholes into 3 groups, well, I could put this into one group, and I could put this into another group, and I could put this into a third group. And now I've separated my wholes into 3 groups. I'm going to do the same thing with my tenths. There's 1, 2, 3, 4, 5, 6 of them. Well, I know that if I take 2 away and make that one group, and take 2 away and make that a second group, and take 2 away and make that a third group, I can split 6 into 3 groups. So now to find my answer, I see that I have 1 whole and 2 tenths in each of my groups. So 3 6/10 divided by 3 equals 1 2 tenths, or groups of 1 2 tenths. So that's how I could use my models to solve it. If you'd rather solve it using partial quotients, we're going to set it up like a normal partial quotients division problem. And then what am I going to do? Just like with multiplication, I'm going to hop that decimal out. Now it becomes 36 divided by 3. Well, I can use my strategy of covering up the numbers if I want. So I cover up that 6 and I say, how many times can 3 go into 3? It can go into it 1 time. 1 times 3 is 3, and I need to add a 0. If I add a 0 to the inside, I add a 0 to the outside. So I'm really doing 10 times 3. Subtract it out, and I get 6 left. I know that 3 can go into 6 2 times. 2 times 3 is 6. Subtract, and you get a smiley face of a 0. We add it up. 10 plus 2 is 12. The last thing that I need to do is make sure my hops are even. If I have 1 hop on the inside, I need 1 hop on the outside. And when I hop it in, I get the same answer that I got before, 1 and 2 tenths. So either way you do it, the answer to 3 6/10 divided by 3 is 1 and 2 tenths. One more problem. Number 13, Lucy used place value models or algorithm to find the sum of 2 65/100 plus 4 18/100. Show how Lucy may have found the sum. So what this is saying is that you can use models or algorithm to solve this problem. So the first thing I'm going to do is algorithm. So I'm going to sing my song. When you add decimals, this is what you do. Line up your decimals straight and true. If you see a blank space, which I don't, you can put a 0 in. Then we're going to add it up from right to left until we reach the end. 5 plus 8, that's 8, 9, 10, 11, 12, 13. I'm going to carry my 1. 6 plus 2 is 8. I'm going to bring down that decimal. And 4 plus 2 is 6. So the sum of 2 65/100 and 4 18/100 is 6 83/100. If I wanted to use models, I could simply draw 1, 2 wholes, 6 tenths, 1, 2, 3, 4, 5, 6, and 5 hundredths, which I do as X's. 1, 2, 3, 4, 5. I'm going to use a different color here to help me out. 4 wholes, 1, 2, 3, 4, 1 tenth, and 8 hundredths. 1, 2, 3, 4, 5, 6, 7, 8. And all I do now is count them up. So I've got 1, 2, 3, 4, 5, 6. I've got 6 holes. 1, 2, 3, 4, 5, 6, 7 tenths. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hundredths. But I can't actually have a 13 in the hundredths place. So I'm going to regroup this 1, and I'm going to add it to the 7. That turns it into an 8. So I have 6 holes and 83 hundredths. Again, whether you use models or algorithm, the answer is the same, 6 holes and 83 hundredths. So there you have it. That's how we would solve those problems. Be sure you know how to solve them for your test on Friday. And if you have any questions, come ask me tomorrow in class. See you then.